Okay, hello everyone. In this video, we are going to discuss some numerical based upon Fourier transform. In our last class, we have been discussed in detail about Fourier transform of a function, that how we can transform a function which is in one domain will be transformed to another and vice versa. In detail, we have been discussed. So I suggest before you are going to watch this video, numerical video, you just watch this video. Okay, Fourier transform video. Now we are going to start our today's video. This is your first question, that find the Fourier transform of a function that is your fx equal to 1 for x mod less than a, 0 x mod greater than a. So here x mod less than a, that means the limit of x in between minus a to a, that we know. X lies in between minus a to a, and x mod greater than a, that means x lie greater than a and x less than minus a. These things we know that we are going to put at the time of integration. So we know the in general the Fourier transform, in short I written f dot t of a function fx is ft of fx, or we can write capital F of omega equal to 1 by 2 pi root over minus infinity to plus infinity fx e to the power iota omega x dx, and here we know iota is nothing but minus 1 root over. Okay, here iota is nothing but minus 1 root over. For this case, f omega, capital F omega will be 1 by 2 pi. In general, we can write minus infinity to plus infinity limit, but for this case, limit already has been given, that function exists in between minus a to a. But for x mod greater than a, that means for x greater than a and less than a, if this is your x-axis and this is your minus a and plus a, in between this range, the value, function value is 1, and above a 0, below minus a also 0. So in this range, the if this is value is 1, the function fx value is like this. So fx exists in between minus a to a. So that limit we have to put. So here minus infinity to infinity generalized, in general we can write, and this minus infinity to infinity can we segregate as minus infinity to minus a, here minus infinity to minus a, then minus a to a, minus a to a, then a to infinite. Okay. So this value will be 0 because fx does not exist in between this range, and this range also does not exist. So for in this range minus a to a, function value is your 1. We have to just substitute 1 e to the power iota omega x dx. Just integrate e to the power I omega x. It will be already 1 by 2 pi root over is there. 1 by 2 pi root over. This will be e to the power iota omega x by I omega minus a to a is your limit. Now we are going to substitute the limit. Instead of x, it will be e to the power I omega a minus e to the minus I omega a by I omega. First I substituted upper limit a, then lower limit minus a. Okay. Now here 1 by 2 pi root over is there, into I multiplied 2 and divided 2. Here omega I taken outside and I is there 2i. We know that e to the power I omega a minus e to the minus I omega a will be 2i sin omega a. That is e to the power ix minus e to the minus ix is nothing but 2i sin x, because e to the ix is your cos x plus I sin x minus this e to the minus x is your cos x minus I sin x. So this will be 2i sin x. Already 2i is in your denominator, so it will be got cancelled, and we can found sin omega a by omega, and here 2 is there, 2 and root 2. So we can found 2 by pi root over sin omega a by omega is your answer. Okay. Next question, question number 2. We have to find out the Fourier transform of fx. Value is your x in between minus a to a, that is your mod x less than a, mod x greater than a, that means above plus a, below minus a is 0. Similar limit what we discussed in your question number 1. So now we are going to segregate in general. Fourier transform of any function fx can be written as capital F of omega is equal to 1 by 2 pi root over minus infinity to plus infinity fx e to the power I omega x dx, and here minus infinity to plus infinity. For this case, above plus a and below minus a, 0 0 value. In between minus a to a, the value is x. So below minus a, that means minus infinity to a, this integration I not written again, and this integration I not written again because these two integrations value will be 0, and minus a to a just I written minus a to a x, because in between minus a to a the value कितना है ये function का x. So here I substituted x into e to the I omega x dx, and here we are going to consider the by parts. This is your first function, this is your second function. The first function written as such, and the integration of second function is your e to the I omega x by I omega. Then a derivative of first function, double integration of this one. The derivative of first function is your x with respect to x is your 1, and double integration of e to the I omega x will be e to the I omega x by I omega whole square or I square omega square, and the limit will be minus a to a. Now we are going to substitute the limit, first upper limit a on this. So here a e to the I omega a by I omega minus e to the I omega a, e to the I omega a by I square omega square is there, okay, minus of minus a we are going to put the limit minus a. Here minus a will be put will be substituted for x e to the this will be minus I omega a by I omega. Then here if the minus is there, minus e to the power, here instead of x minus a, so it will be minus I omega a by I square omega square, right? Okay, 1 by 2 pi root over, here you can see a by I omega, here minus plus a by I omega. From these two terms I taken common as a by I omega, we can get e to the power I omega a, and here minus plus e to the power minus I omega a. Got it? Now here from this term and from this term we can take common as 1 by I square omega square. Here you can see this is minus plus, so I am going to take common plus I square omega square. So this term will be, first we are going to write e to the minus I omega a, then second term is this one minus e to the I omega a. Okay 1 by 2 pi root over, here if I will be take minus to numerator, it will be minus ia by omega, and this value is nothing but e to the I omega x I omega a plus e to the minus I omega a. We know that 2 cos omega a, because this will be cos omega a plus I sin omega a. This is cos omega a minus I sin omega a, so sin plus I sin minus I sin will be got cancelled, so we can get 2 cos omega a. Similarly, considering this one, we can found 2i sin omega a, and here I square value is your minus 1, and if I am going to consider, see, this is the e to the I omega a minus e to the I omega a, but we know that e to the I omega a minus e to the minus I omega a is your 2i sin omega a. So first we are going to take common minus, then it will be e to the I omega a minus e to the I omega a. So this will be minus, if I will take common, then it will be e to the I omega a minus e to the minus I omega a. This value is your 2i sin omega a, right? And here I square value is what? Minus 1, and this minus will be plus finally. Okay, I just removed one step, you just consider that one. So this will be 2i sin omega a by omega square. So finally we can found the answer will be f omega, or Fourier transform of your fx will be equal to 2 by pi. Here you can see 2 can be taken outside and got cancelled, root 2, though it will be 2 by pi whole root over, and here you can see I taken outside, so this term will be written as first sin omega a, and if I am going to add here omega and omega square, so 1 omega will be multiplied with this term. So first we have to write this one sin omega a, and this will be omega will be multiplied with this term, then a will be there, omega cos omega a by omega square. Okay, this will be the answer of this question number 2. Now we are going to go for question number 3. We have to find out Fourier transform of the function fx which value is minus 1 in between minus 1 to 0, 1 in between 0 to 1, 0 otherwise. So in these two range we have the data of this function, otherwise this function's value is 0. In general, Fourier transform of a function fx that can be written as capital F of omega is your 1 by 2 pi minus infinity to plus infinity this function fx into e to the I omega x dx, that we know. Now we are going to segregate this integration as per given range. So range is given that minus 1 to 0. So first I am going to segregate minus infinity to minus 1, this one fx e to the I omega x, then minus 1 to 0 fx e to the I omega x dx, then 0 to 1 fx e to the I omega x dx, then 1 to infinity fx e to the I omega x. So minus infinity to plus infinity integration segregate as like this. But below minus 1 above plus 1 the value of this fx is 0. So this integral value will be 0 because fx is 0, and here 1 to infinity fx is 0, so this integral value will be 0. Now fx value in between minus 1 to 1 is your minus 1. I substituted over here minus 1 to 1 and fx value is your minus 1 e to the power iota omega x, plus here fx in between 0 to 1 in this limit value is 1 e to the power iota omega x, and this value is 0. I substituted. So this value you can easily find out because e to the power I omega x, this value already we discussed. 1 e to the I omega x integration is e to the I omega x by I omega. Here e to the I omega x by I omega integration limit will be minus 1 to 0, and here e to the I omega x by I omega integration limit will be 0 to 1. You just do by yourself. 2-3 step I not done here, I left for you. You do by yourself. Do by yourself. Finally, you can get the answer. Fourier transform, or that is your capital F of omega will be 2 by pi root over cos omega minus 1 by I omega. Okay. Now we are going to move to our next question. That is your question number 4. Find Fourier transform of a function fx exist in between minus 1 to 1. That means mod x less than equal to 1 means minus 1 to 1. Value is 1 minus x square, otherwise it is 0. That means above 1 below minus 1 the value is 0. So what will be its Fourier transform? Here is the derivation. In general, Fourier transform of any function f of x, suppose that is written as capital F of omega equal to 1 by 2 pi root over minus infinity to plus infinity fx e to the I omega x dx. This is the in general. But the range and corresponding value of fx is given in the question. Accordingly, we have to segregate this integration and we have to put the value. So here the value exists, the function value exists in between minus 1 to 1. Mod x less than 1 means in between minus 1 to 1 the value is exist. Below minus 1 above plus 1 does not exist, value is 0. So I not written those integrals. So this integral can be segregated, or this minus infinity to plus infinity can be segregated accordingly, and we can found capital F of omega will be equal to 1 by 2 pi root over minus 1 to 1 limit only will be exist, other will be other, that means minus infinity to minus 1 limit will be 0, and 1 to infinity limit will be 0. I not written here. So this minus in this limit the functional value is your minus 1 minus x square into e to the I omega x dx. Okay. That implies f of omega will be equal to 1 by 2 pi root over, right? So this is one function, this is another function. Here we consider the by parts. Okay, by parts, and you can consider here Kronecker method. Kronecker method to solve this type of integration instead of by parts. Kronecker method, what is the Kronecker method, how it can be used? About Kronecker method, a separate video I have been uploaded, you can watch that one. But in short, I am going to explain over here that if gx and fx dx, suppose we are going to consider this is phi x. Okay, gx phi x integration, suppose we have this is your first function, this is your second function. Then according to Kronecker method, how we can write? We have to write that gx integration of phi x dx, then minus derivative of gx double integration of phi x dx, then plus g double dash x triple integration of phi x dx, then minus 1 until g derivative of gx will be equal to 0. See, if suppose gx is your x square, okay, so here x square means this will be x square, and first derivative will be how much, 2x, then second derivative will be how much, 2, then third term will be how much, third term will be minus, this is your, sorry, this is the third term, fourth term will be how much, fourth term will be third derivative and fourth integration of ix dx. Here third derivative of gx is how much, 0. So for this case, x square and phi x suppose function is there, then we can have only 3 terms, these 3 terms. So this is the 𝐸 method that I am going to use here instead of by parts. It will be easy to solve this type of integration. So this is your gx and this is your phi x I considered, and I am going to use the 𝐸 method. So gx, first term will be gx integration of this one, phi x. Gx is your 1 minus x square, and integration of this one, first integration, e to the I omega x by I omega, minus derivative of gx, that means 1 minus x square's derivative, how much, minus 2x. Okay, minus, all minus has we have to put, then derivative of this one will be minus 2x, double integration of this one, already first integration we have, then another integration of this one will be I omega x by I omega or I omega square, already I omega is there, then derivative of the फर्स्ट, दिस इज फर्स्ट टाइम डेरिवेटिव हुआ, सेकेंड टाइम डेरिवेटिव अगर मैं जी एक्स का करूँ तो कितना होगा, सिर्फ -2, एंड ट्रिपल इंटीग्रेशन ऑफ दिस फाई एक्स, ऑलरेडी डबल इंटीग्रेशन होके इधर लिखा हुआ है, तो ऑलरेडी डबल इंटीग्रेशन के बाद ये है, अगर ट्रिपल इंटीग्रेशन करूँ देन नेक्स्ट टाइम इंटीग्रेशन इफ आई एम गोइंग टू डू दिस टर्म, देन another I omega is going to be multiplied with the denominator, so e to the I omega x by I omega to the power 3, then other terms will be 0, because next I am going to do the next derivative of gx, means minus 2's derivative will be 0. Okay, other terms would not appear. Now yes, here I done the integration, the limit was lower limit -1, upper limit 1 I written. Now we are going to substitute the upper limit first, then lower limit. Carefully you just watch. First I am going to put the upper limit. Here I am going to put the upper limit 1, here 1 square, 1 minus 1 0, so this term will be 0. Got it? Okay, then 1 I substituted over here, 1 sorry, minus plus 2 into 1, e to the I omega 1 I have to substitute, e to the I omega by I square is how much, -1, so -1 omega square written over here. Then here I am going to substitute 1, that means here I have to substitute, here x is there, so -2 e to the I omega by iq is nothing but minus I and omega q. Okay, minus, again I am going to substitute -1 as the lower limit. So if I am going to put -1 over here, -1, x square is there, -1 square itself 1, so this term will be again 0. Right, here I am going to put -1, so this will be plus, minus is there, so it will be -2 e to the power -1. If I will put instead of x, it will be minus I omega by this is your minus omega square. Again I am going to put here -1, -2 is already there, -2 e to the minus I omega by minus I omega q. Right, that implies capital F of omega will be equal to 1 by 2 pi root over, here you can see I am going to take common. See, this is your -2 by omega square is there, and here in this term minus plus, this is minus, so -2 omega square, 2 by omega square is there, so I am going to take common -2 by omega square from this term and this term. It will be e to the power, in bracket we can write e to the power I omega plus e to the minus I omega. Got it? Next, here 2 by I omega q, here minus plus, here minus plus, another minus is there, so minus, so 2 by I omega q I am going to take common from these two terms. So if we are going to take 2 by I omega q, then this will be rest factor is your e to the I omega, and this is your e to the minus I omega, right? And we know that e to the I omega, e to the minus I omega plus is nothing but 2 cos omega, and this is your e to the I omega minus e to the I omega is nothing but 2i sin omega, 2i sin omega, 2i sin omega. Okay, so here this is your 2 to 4, I got cancel, and this is your 4, so we can take 4 outside, or written as such 1 by 2 pi root over 4 by omega q. If I am going to add together, if I'm going to add together, then this is your omega q, this is your omega square. So omega will be multiplied, one omega will be multiplied, and this is your minus itself. Minus means this term will be written as second. So if I will do so, then 4 by omega q, this will be the term first I have to write sin omega minus omega cos omega, right? So 1 by 2 pi root over 4 by omega q sin omega minus omega cos omega. Okay, let this is your equation number 1. Actually, I forgot to write the full question. The question was actually we have to find out the Fourier transform of this function. Then by using the Fourier transform of this function, we have to evaluate one integral. Okay, find the Fourier transform of this function, this one, then use it to evaluate this integration, actually 0 to infinity x cos x minus sin x, x cos x minus sin x whole divided by x cube into cos x by 2 dx. Okay, we have to evaluate this integral by using Fourier transform of this function. Okay, I forgot to write. So here we evaluated the Fourier transform of the given function fx is this one. Let this is your equation number 1. We know now we are going to consider the inverse Fourier transform of this one. So this is the Fourier transform of whose? Fourier transform of fx. So Fourier transform of fx is f omega. If I am going to consider inverse Fourier transform of this f omega, then we can found the fx, right? By using inverse Fourier transform, we can evaluate this integral. How it is? Here you can see. We know the inverse Fourier transform of f omega, f capital omega. In general, what we can write? Inverse I dot f dot t of f capital F omega is nothing but fx equal 1 by 2 pi root over minus infinity to plus infinity f omega e to the minus I omega x d omega minus I omega x d omega, that we have been discussed in our last class. Okay, so if Fourier transform of a function, we are going to write e to the plus I omega x, corresponding inverse Fourier transform will be minus iota omega x d omega. Now f omega, already we found this one. We have to just substitute this value instead of f omega. I just substituted this value. Equation number 1 just substituted. Okay, is equal to, here you can see, here 4, here 2 pi root over. The denominator will be how much? It will be 2 pi and 4. So obviously it will be 2 by pi. 2 by pi minus infinity plus infinity 1 by omega q sin omega minus omega cos omega into this one e to the I omega x is nothing but cos omega x minus I sin omega x d omega. Now I am going to multiply this term and this term. We can get 4 terms. Okay, what are the 4 terms? Minus infinity to plus infinity. This see e 2 by pi I written outside of the integration. Minus infinity to plus infinity 1 by omega q. This one sin omega multiplied with the cos omega x. Sin omega cos omega x d omega. Then sin omega multiplied with this one. Minus infinity to plus infinity 1 by omega q sin omega I sin omega x d omega. Then this term multiplied with the cos omega x, omega cos omega x dx, and this term multiplied with this one, this value. Here this integral and this integral both are same, can be cancelled out, and we have only 2 integrals, this one and this one I written as such. Okay, this integral I written here, this integral I written here. Now we have to put x equal to 1 by 2. So here what we found? We found fx. So fx value we found this one. If I am going to put instead of x equal to 1 by 2, so this will be f of 1 by 2 will be equal to 4 by pi. 4 by pi 0 to infinity 1 by omega q sin omega into cos. Instead of x we have to write omega by 2. Sorry, instead of omega x we can write omega by 2 because x is your 1 by 2. So omega by 2 d omega, and here 0 to infinity 1 by omega square cos omega. Instead of omega x, instead of x we can write 1 by 2, so omega by 2 d omega. See why it is written as 4 by pi? Because integration here integration minus infinity plus infinity, if I will be consider 0 to infinity, so 2 will be multiplied, then it will be 2 into 2 will be 4 by pi, right? Now here you can see that f of 1 by 2 value is 1 by 1 by 1 minus 1 by 4. Why? See, in your question it has been given that f of x equal to 1 by 1 minus x square, which is exist in between minus 1 to 1, right? Exist in between minus 1 to 1, exist in between minus 1 to 1. So here at this is 0, so this is the middle point, is nothing but x equal to 1 by 2. So at x equal to 1 by 2, if I am going to consider x equal to 1 by 2, so this value will be 1 minus 1 by 4. Same thing I have been substituted over here. For f half, it will be 1 minus 1 by 4 equal to 4 by pi. Here cos omega by 2 can be taken common from these two integrals. We can write cos sin omega minus, see here, cos omega by 2 taken common from these two terms. Here omega cube omega square. If I subtract these two terms, then one extra omega will be multiplied with this cos omega. Same thing it has been written, cos sin omega minus omega cos omega by omega cube. I just subtracted these two terms, taken common, cos omega by 2 d omega, right? So here 1 minus 1 by 4 is your 3 by 4 is equal to here I taken minus from this, minus common from these two terms. So it will be minus 4 by pi 0 to infinity. Here first term will be written, this term will be written first, omega cos omega minus sin omega by omega cube cos omega by 2 d omega, right? So here minus 4 by pi, if I will take this side, it will be minus 3 pi by 16, 4, yes, 16, 0 to infinity, omega cos omega minus sin omega by omega cube cos omega by 2 d omega. So here omega is a dummy symbol, can be changed to x. If it is so, then this integral will be written as 0 to infinity x. Instead of omega, we have to put x cos omega x minus sin omega x by x cube into cos x by 2 dx will be equal to minus 3 pi by 16. Okay, 3 pi by 16. That is your answer. So in this video, we have been discussed in detail few numericals based upon Fourier transform. Okay, in our next class we are going to discuss Fourier transform of a Gaussian distribution function, that is your e to the minus ax square. This is a 1D Gaussian distribution function. Thank you so much for watching this video. If you like this video, do subscribe and share.